we have been asked a question. The radii of curvature of both the surfaces of a lens are equal. If one of the surfaces are made plane by grinding, how will the focal length and power will change? As you read the question, you should realize that they're talking about a lens and the lens have same radius. First of all, let's write the equation. That's a good way to approach a question. The equation, lens makers formula, we will apply lens makers formula here. 1 by f equals and then minus 1 by r1 minus 1 by r2. Now what is given in the question? The radii of curvature of both the surfaces of a lens are equal. So there's a lens, this is a lens, this is the first surface, this is the second surface. This will be r1, the radius respect to the first surface. This is r2, the radius with respect to the second surface. And here they say that r1 equals r2, right? R1 equals to r2. And then they ask if one of the surfaces is made plane, one of the surfaces are made plane by grinding, how will the focal length change? So you should know that for a glass slab, for a plain glass slab, the focal length is infinite. So we have to find how will the focal length and power changes. How does it change? So in the beginning, let's take the first case when the lenses are both have a sphere surface. So 1 by f and minus 1 by r1 minus r2, that is equation. And r1 equals r2 equals, they're the same, let's give it r. Both are equal, both the radiuses are equal. Also you should see that here r2, the radius with respect to the second surface, is negative. Why? Because as per the sign convention, it will coming on the left side, and as per the Cartesian sign convention, anything on the left side is negative. You have to take it as negative. So r2 is negative. So the equation changes. Now it becomes 1 by f and minus 1. This is what the equation will look like. Try it and you will see. Now you can say that this r square and r, they will cut off, so it becomes 1 by f equals and minus 1, and minus 1 stays the same, and 2 by r. This is what it becomes. And we also know that 1 by f, focal length reciprocal, is power. Power p equals 1 by f, and f equals 1 by p. So that means that p equals and minus 1 2 by r here. So we found the power for the first case. Now when the second case comes, when one of the surfaces made plane, one of the surface has been made plane. Let me just get a board. So now it has become like a plane, right? So when it becomes plane, I told you the glass slab focal length becomes infinite. So what happened to the radius? What happened to the radius? For a glass slab, there's no radius, right? The radius it has become infinite. The radius itself has become infinite. So that means in the second case, 1 by f, the equation, and minus 1, the new focal length. Becomes, and minus 1 is equal to 1 by r1 stays the same minus R2, just look at it. Where is its radius? No, it's to the infinity. We'll consider this one to the infinity. So 1 minus 1 by infinity. 1 by infinity equals 0. 1 by 0 equals infinity. 1 by infinity equals 0. That means 1 by f equals n minus 1 1 by r1 minus 0, which means n minus 1 into 1 by r1. That's 1 by f, which is also equal to p. So this is the new power. So we have two powers, p1 and p2. p1 was for the first case and p2 was for the second case, and this is now what looks like. See, you can see that p1 is 2 times greater and focal length is inverse of power, so that means that power has been doubled. Power has been halved. It has been halved. It was 2 by r, now it's 1 by r. That means p1 was multiplied by 1 by 2. That means power will be halved. They asked what changes to the power, so we have to show them what was the change and what is that. We have to also tell them what is the power is. Power will be halved, and focal length is inverse of this. So this is 1 by f. So f, you can, if you see f 1 by f, if you turn it to f and you inverse this whole equation, you will see that focal length is doubled. That's it. Now let's move on to the next question. Here's a quick plug. There's this equation called refraction at a spherical surface in this chapter, which is n2 by v minus n1 by u equals n2 minus n1. Now this equation is when the light is traveling from a rarer to denser medium. Now for denser to rarer medium, we have n1 by v minus n2 by u equals n1 minus n2 by r. What's the difference? You can see that when it's rarer to denser, where the first medium has a low refractive index, rarer medium has less refractive index than denser medium. So here n2 is greater than 1, so that means n2 will come first, right? And here n1 is denser, so n1 will be greater than n2, and n1 is coming first. That means the equation cannot be negative. So that's just one way to memorize this equation. So the next question is, a beam of light converges at a point P. Now a convex lens is placed in path of the convergent beam at a point 15 cm from it. At what point does the beam converge if the convex lens has a focal length 10 cm? Now they say, let me get the board. A beam of light converges at a point P. So this is a point P. A beam of light converges at this point, and we call it as P. Now a convex lens is placed in path of convergent beam. It is placed in the path, so you have to draw this when this light has been coming. You can't place it here, you can't place it here, you have to place it here to the left hand side, because they say in the path of the convergent beam. This is the path. After this, it has been converged and it is going to the infinity. You have to place it here. If you read the question, you will understand. So we place a convex lens. We at a point 15 centimeter from it. That means this lens has been placed 15 centimeter away from point P. So this is 15 centimeter. At what point does the beam converge if the convex lens has a focal length 10 centimeters? So after this convex lens has been placed, the convergent beam will be displayed. It will show some change. It will show a change in its path. Refraction will take place. So we have to find the new position of this convergent beam. We have to find where does it converge after this lens has been placed. So we will be using the thin lens formula, which is 1 by f equals minus 1 by u plus 1 by v. Now what our values have they given us? They have given us the focal length, which is f equals 10 centimeter given in the question, focal length of the lens, and u is the image of the image of the object, sorry, object distance from the lens. So u is 15 centimeter, and note that the object is to the right of the lens, so we will be taking positive sign. V is unknown, we have to find v. So here's the object, we will have a light here, the light is coming from actually here. Now we have to find where will be formation of v. Now you have to put these values into this equation. 1 by 10 equals, I will do, you do it yourself, 1 by v plus, you will get 6 centimeter as the answer. You'll get 6 centimeter, v equals 6 centimeters. That means you can say that v will be somewhere around here, 6 centimeter towards next. Another quick plug, if the question says that it's a concave lens, this is a concave lens, I know the diagram is shit. If it's a concave lens, the power should be taken negative, but in this question we got it as positive, so for convex lens power we took it as positive. But if in the exam you see it as concave lens, you should take the power as negative. That means 1 by f, the focal length should be taken as negative. Now the next question is pretty interesting. It says, I hope you can read, a convex lens is placed, I hope you can read, okay, but a convex lens is placed in contact with a plane mirror, a point object at a distance of 20 centimeter on the axis of this combination has its image coinciding with itself. What is the focal length of the lens? So what's happening here? What is actually happening here is, so let me show you, let me show the diagram of what's happening. Give me a sec. This is a combination of a concave mirror, a concave lens, right? Yeah, a convex lens, and a mirror, a combination of a mirror and a convex lens, a plane mirror and a convex lens. So they are saying that a point object at a distance, a point object here, let's call this as O, this is the object O, is placed 20 centimeter from this combination, 20 centimeter from the combination. So because due to this combination, the image of this object is coinciding with this object. Yes, so let's say the light rays get refracted and reflected and they come back, and the image formed due to this object from this combination is coinciding with the object. That means the image I is formed at O. Wow, damn. So what's happening? So they're asking what is the focal length of the lens. Now how can we find this? But you have to understand what's happening here. So the combination is of a lens, that to a convex lens, and a reflecting mirror, a plane mirror. So light rays, imagine that light rays are going then they get refracted and they come back, right? So they're saying that it comes back here. That means first of all it will reach here, and then something happens, refraction takes place, and then it should hit the plane mirror, then it should come back to the convex lens, and then after that they're saying the image is formed at the same place of that object. That means the when it comes back, this path has been retraced. How it went from the object to the combination was like this, and then the same path was retraced. That means we can say that it got refracted and then it hit normally on the mirror. For retrace, for if it has to be retraced, then the refracted rays must fall normally on the mirror. Then it will get reflected. It will get reflected back how it got from here, and then it will retrace its path, and that's how we will get the image and the object at the same place. That's how the object and the image will coincide with each other. So what can we say? It got reflected from the mirror, then it will come back to it will go inside the convex lens, and when it goes to the convex lens, the ray will coincide at the focus of this convex lens. That's what happens when a light ray passes through a lens. It will coincide at its focus. That's what happens. So that means we can say that the focus of the convex lens is 20 centimeter. That's it. That's it. Okay, I think I can improvise that answer if you still don't understand it. The object gets, they say that it gets back here. What happens? Just think about it. First, it must go through refraction, right? The object is here. The ray from here first goes through refraction, and then it will get reflected, and then they say it goes back to O. That means this path has been retraced, and for it, if it has to be retraced, it must be reflected by the mirror normally. That means the refracted ray must fall normally to the mirror, and then and only then this path will be retraced. And as this path will be retraced, this new ray will go at the focus. Why? Because convex lenses are converging lenses. Convex lens are converging lens. That's why this reflected ray will go at the focus, and they say that the image is formed at O, which is where the object is kept. That means the object was already kept at the focus. That's why the image is formed at the focus. That's why the image is formed at O. That's it.